Electronics lesson 5. I would like to welcome you to the VVSM Academy. In the last class, we have done about Bohr's atomic model, how it relates to conduction band and valence band in semiconductors. Well, friends, energy band theory, conduction band. A valence electrons are attached loosely towards the nucleus at room temperature. Some of the electrons from valence electrons will leave the band freely, which are free electrons. That's why they are called valence electrons. So these are called the free electrons because they flow towards the neighboring atoms. These free electrons will conduct the flow of current within a conductor, which is known as conduction electrons. So the free flow of electrons within a conductor is called conduction electrons. Hence, the band which includes electrons is named as conduction band because the series of band formation, the series of conduction electrons, band after band, that is a series of formation, the band which includes electrons, that's called conduction band. And the occupied energy of this will be the less occupied energy. Whatever the energy occupied during the formation of conduction band, it is very less. If you observe here in the band energy, this is conduction band. Next, we will pass on to the forbidden gap. The forbidden gap is the gap between the conduction band and the valence band. This band is forbidden, one without energy. Therefore, there is no certain flow in this band. Forbidden. No flow of electrons. The flow of electrons from the valence to conduction will pass through this gap. The flow of electrons will pass through this gap. That is very important. If this gap is greater, then the electrons in the valence band are strongly bound towards the nucleus. At the present, in order to drive the electrons out from this band, a little outside force is necessary to communicate, to push the electrons, which is equivalent to the forbidden energy gap. In the following diagram, the two bands as well as a forbidden gap is illustrated below. Based on the gap size, the semiconductors, conductors and insulators are formed. How we will call this, some of the matter exists in the form of a semiconductor, in the form of a conductor, in case of insulators, that is conductors and insulators. We are studying conductors and insulators in the previous classes. So in between the conductors and insulators, there is a state of matter which is semiconductors. How this gap, these based on the gap size, the semiconductors, conductors and insulators are formed. That means the gap size, that is forbidden energy gap, is very very less, or even there is no forbidden gap, means they belong to the category of solids. And in case of insulators, for example, in insulators you can have the conduction forbidden energy gap. How it is, whether it is less or more or even zero, depending upon the nature of the gap size, depending upon the forbidden energy gap. That is how the conductors or insulators or even semiconductors are formed. Energy band theory. According to the theory of energy band, the energy bands are classified into valence band, forbidden energy gap and conduction band. Now coming to the conduction band, here observe the figure. This is the energy level, this is the y-axis, and this is the x-axis. Suppose if you observe conduction band, the gap is very less in case of solids or in case of metals. The conduction band and valence band, in between the conduction band and valence band, this forbidden gap, the band gap is very less in case of metals. Suppose if it is more in conduction band, the band gap is more. This is in between conduction band and valence band. They comes to the semiconductors. Suppose in case of insulators, the band gap is still larger. This comes under insulators. This is the forbidden gap, band gap is also called as Fermi level. That means depending upon the Fermi level, the metals, semiconductors and insulators, the properties of these are purely depends upon the Fermi level or the gap, forbidden gap, band gap is very important phenomena in the conductivity in metals, semiconductors and insulators, my dear friends. Thank you for listening. See you again